All right, good afternoon. My name is Sam Atkinson. I'm a software engineer at AWS. And today I'm going to be talking about visibility that scales. I work on the FSx for OpenZFS team. Today we offer a couple of file systems of these single tenant file systems in AWS, manage them for customers, make a whole bunch of cool automation for them and features and benefits so that they can run their file systems in AWS. So I'm gonna start today by giving a quick overview of what FSx is for those of you that don't know. A quick overview of our customers and a couple of interesting workloads that are being used on FSx. And then I'm going to spend most of the time today talking about something that our customers want and a problem that we have with what they want and how we're fixing that with OpenZFS, some challenges with that, some solutions with that, and then we'll wrap it up with some next steps. So just a quick overview on FSx. I spent a bunch of time on this last year, so I'll try to breeze through this. But Amazon FSx it's an AWS service which allows customers to launch, run, and scale feature-rich and performant file systems with a few clicks. We have several different types of file systems today, all of which offer highly available and/or highly durable deployment options, various types of data encryption, and are pretty cost-effective. So just a quick kind of timeline of FSx. We launched in 2018 with support for Windows and Lustre. In 2021, we launched support for NetApp ONTAP and OpenZFS. And then in last year, 2023 and 2024, we added a lot of support for more highly available deployment options, and then cross-file system replication support, send, receive. And so there's obviously a lot missing here. We've done a lot in the last several years, but I just want to show we've put a lot of investment and a lot of time in expanding what we offer in OpenZFS and bringing more customers to the service and using OpenZFS. So why, back in 2021, did we start offering OpenZFS on FSx? We found a few common customer workloads that were having trouble kind of figuring out what's the optimal file system. For my workload, we have a bunch of file systems in AWS. Why is one not working? Why do we potentially need to introduce another one? And we found that a lot of these customers were using workloads that fell into a couple common categories where high performance databases or source code version control and software builds, ML and AI a little bit, EDA, electronic design automation, some media rendering and transcoding. So these were all workloads that had a couple of common traits. They were usually pretty latency sensitive. They were IOPS intensive. They were looking for some business management capabilities that you'd see in a lot of file systems today, taking snapshots, restoring those snapshots cheaply, and then overall, just being a cost-effective solution that they can take their existing NAS, put it in AWS, and not have to do a whole lot of heavy lifting, to get up and running. So let's talk about I guess what customers love about what we introduced when we started offering OpenZFS in AWS. So I'll start with customer Amdocs, who does the software and services provider for telecommunications and media companies. They do a lot with high-performance databases. They do a lot of database copies. And so they were facing some operational costs and management challenges when creating database copies on their previous storage solution. So they needed instantaneous high-performance copies of these databases, perfect fit for OpenZFS and snapshots and clones and such. And so they were able to switch over to FSx for OpenZFS, reduce their relational database footprint by 60%, reduce their overall data by 5x, and more than double their aggregate throughput. Another customer I'll just quickly talk about is Astera Labs. They're a leader in connectivity solutions that remove performance bottlenecks throughout the data center. They were using a self-managed OpenZFS NFS server, and they were running into a bunch of limits on performance and around total storage. And then by moving to FSX for OpenZFS, they were just able to get sort of an easier setup, a consistent high-performance file system, and access to virtually unlimited storage capacity in AWS. All right, so you've seen two customers here having success with the service, but there's a lot in the weeds. There's things that are missing that customers would like. And so let's talk a little bit about this middle sort of category of things that customers love. These advanced ZFS capabilities. So what are we talking about when we talk about these capabilities? So these capabilities we're talking about are these interfaces that customers are using. These are the only interfaces that they have to interact with to use FSX for OpenZFS today. So when they're administering their file system, whereas they might have previously used a ZFS CLI command, libzfs, before they're going to be using the Amazon FSX API, SDK, console, et cetera, to do things like create, modify, and delete datasets, scale, provision, throughput, storage, and IOPS. Their workload, they're using NFS like any other NAS that they're coming from, and then they're able to use this container storage interface driver, the CSI driver, to really quickly and easily attach storage to Kubernetes nodes. And then the cool one that we'll focus on today is monitoring. So to understand file system performance and analyze user activity, they're using Amazon CloudWatch metrics, which lets them use a really clean user interface in the AWS Web Console to go and look at what's going on in their file system, where they might have bottlenecks, where they need to scale, et cetera. So what do they want? What's missing here? So in particular, in that administrative category of interfaces, we started to see a common pattern where customers that were isolating like downstream teams or customers within data sets were using user and group quotas within those data sets to limit usage for each of those downstream teams or customers. And so they were often like heavy users of user and group quotas. And so it makes sense they would want to monitor those user and group quotas. And so they often had trouble like understanding user activity or taking proactive action against workload interruptions when they might need to scale storage before they run out of space so that no one's stuck when the file system runs out of storage capacity. And then identifying noisy neighbors so that they weren't blindly scaling up when one or two users was like using more space than they should have. So great, because customers want this quota monitoring, and ZFS has native support for quota monitoring with this ZFS user space command. So what's the issue? So the issue is we might not have a place that it fits perfectly. So we only have these interfaces to work with right now. There's certainly potential to add more, but for now we have these couple of interfaces. And so there's one missing here, which is there's no ZFS CLI, there's no libzfs for customers to work with. So we have a little bit of a challenge. So we have a couple of options. Maybe we put the user group quota utilization in the FSX API. We do, maybe something like this. Possible, but if we lay it out like this, you might see that we could very quickly blow up the size of an API payload. The limits on user and group quotas and the number of users that you might have using your file system is not usually known ahead of time when they're provisioning their file system. And so this list can grow massive, and so in a single request or response, we're totally blowing up the payload size. It's not scalable. We could paginate, but then we're running into TPS limits where if they have upwards of millions of these, we're looking at a lot of TPS being added to our front end, and maybe that's not scalable either. Storing this information also is not cheap. ZFS already does it for us, but we'd have to store it on our own to be able to expose it through our API. So this whole thing, like maybe there are some scaling challenges here. Well, if we don't have other options that will work, like this may end up being the direction we go. We'll see. But it's common for customers to have pretty enormous numbers of users. So scaling issues could be something to think about here. Another option, maybe we use Amazon CloudWatch metrics. It's something they already go to, something they already use to monitor their file system. They can quickly analyze patterns in utilization. They can do some pretty cool stuff with CloudWatch metrics integrations. They could, for example, create alarms that fire when a certain quota is approaching whatever 90% utilization, and then take some action automatically to kick off maybe a storage scaling operation, or notify them, send them an email, that they're a little too close to their threshold. So there's some cool stuff they could do here. And then finally, ZFS tooling, the ZFS user space command, maybe that's an option too. Maybe we figure out a way to expose that. All right, so we come back to where does it fit? We've looked at these options, and the missing one, which would make the most sense, maybe naively, using like just the ZFS user space command and exposing that, is not here. So why is that not here? So a couple reasons. We're trying to sort of balance these core tenets in these interfaces that we expose. So the reason that we don't, just give them a shell to the file system today is for a couple of reasons here. We're trying to minimize the attack surface, so limiting the interfaces that they have available that we don't today offer, shell access or iSCSI, a couple of other protocols. We're trying to maximize parity with libzfs, give them hopefully, an interface to do things like look at zpool iostat, look at the properties of the data set, and then maximize performance. So trying to minimize like the cognitive overhead of, having to think about what super low level tuning do I need to change? When I provision my file system, like they shouldn't have to think about that because we know what hardware we're putting the file system on. We should know where, what a lot of those tunings should be ahead of time. And so if we can take that out of the picture and sort of guarantee to them that, yes, as your workload changes or if the hardware would change, like we're doing our part on our end, changing those so that you don't have to think about it. So enter this high cardinality telemetry problem. So the next best thing that, option that we have for this user and group quota utilization might be the Amazon CloudWatch metrics. It's a really nice system for looking at history and doing automation, adding, little hooks to events that happen when they approach user and group quota utilization thresholds. So let's look at that. So we talked a little bit about the ZFS tooling. This is being requiring shell access, being a pretty big undertaking to mitigate security risks. It's something that we're looking at doing in the future, but for now it's not something that we're doing immediately, just to keep our sort of security plane as tight as possible. We talked about the API that doesn't scale. So finally, Amazon CloudWatch metrics, what's the problem here? So the way that Amazon CloudWatch will sort of store metrics today is using these dimensions. You can think of it a lot like a database, that every combination of metric and all of its dimensions is stored and indexed independently. So when you would store a single data point for a single user's quota utilization on a particular volume or data set, you have now inserted one row into your database that's going to be indexed totally separately from everything else. So basically, when you have many of these combinations, querying them is super inefficient and super costly. So a common example here, a totally reasonable thing for customers to do, have 10 file systems, say, have 500 data sets, have 500 users on each data set. You're now looking at 5 million unique metrics. And you can't query 5 million unique metrics with one API request. You need a lot of API requests to get that. So it's not efficient. It's not what they're looking for. So what other options do we have? So platforms and services exist for this kind of high cardinality telemetry. We already have just tons and tons of combinations of dimensions that are stored independently, but they're inherently expensive. They often trade off costs with short retainment restrictions, but they're still super costly because you're storing and indexing data at a really highly granular kind of way. So if you had if a customer had 1 million data sets, how do they make sense of the state of the world? How are they looking at a single user that has usage across all of their 1 million data sets? Are they querying 1 million? Are they making an API request 1 million times and then adding that up? Is that something that they should have to do? Probably not. And then if we're managing 1 million file systems with 1 million volumes or data sets each, can we efficiently scale? So how do we balance these? So let's talk about the solution that we've been looking at most closely. So we started asking customers, do you really want this this expensive quota utilization history forever? Is it useful to have it forever? What do your access patterns look like? And we started finding that they usually involved searching for something either at some period, at some repeated period, or when some event happens. So when, a customer would report, when a customer's user would report, hey, I'm getting eno space here, what's going on? Then they're going and looking at what's the quota utilization and what can I do about it? Or maybe they're running, once a day, they're doing an aggregate, look at all of the data sets, looking at every team's usage, at every customer's usage, where either some quota limit is being approached, file system ran out of storage, or they're just looking at usage across teams or projects. So they don't need it forever. So this is granular data. It's already stored efficiently in OpenZFS. The FSX API and CloudWatch metrics maybe don't meet customers' requirements. Is there something that we can do in the data plane with that third interface, with the data plane interface? And what if customers could access metadata in the file system itself across NFS? So this is something we looked at last year during the hackathon and had little success at that time, but we have made a lot of progress on that this year. So we looked at using the .zfs directory, the ZFS control directory, to add in more of these pseudo files. So doing having a procfs almost in .zfs. So there's precedent here, the ZFS snapshots and I think it's shares, thank you. Directories are already in there where you can go and look at your snapshots and in a read-only way. So there's precedent there. It's zero cost because we already have the ZFS user space command. It'll go and use libzfs and look up in a really efficient way, show me what all of the usage is across different users. It's instant and it's always up to date. The instant and always up to date are two unsolvable problems if we use any other interface to do this. So there's there's a lot of benefits here. So we spent some time working on this last year. There's a pull request up to expose this information in the way that you see here, but it's not. There's some complications that we'll talk about. So let's take a look at some of these properties of these pseudo files. So like I said, it's similar to procfs. It uses the same interface as a lot of procfs files. the Linux sec file interface. So you'll see here that when we stat this file, it looks like it's 0 size, and that's nice because when we go and read the file, we'll just at runtime go and fetch everything from ZFS and return the whole list of users and groups in real time. It's great, no storage cost. But what's the issue here? So like I said, the size looks like it's 0. So the challenge here is with NFS. The NFS client today, and at least in Linux, and actually this is the case in a lot of NFS client implementations, has this optimization that you see here, where if it will always stat the file first, and if it sees that the length of the file is 0, it will optimize out a read, and it will just give you an empty page. So not ideal here. So a couple questions immediately arise. Can we change the Linux NFS client implementation? Maybe. Should we change the Linux NFS client implementation? Maybe. If we did change the implementation, what are the hazards? What are the mitigations? Should the pseudo file contents allowed to be cached? If it's a procfs-like thing, maybe not. And then we spoke a little bit with the Linux NFS client maintainers. They were like, it makes total sense. If you use ODirect, this is a perfect fit because you're not putting anything in the page cache, and you're treating it exactly like you would have a procfs file. So if you force your clients to use ODirect to read these, then fine. You can make that change. So great. So we can change the Linux NFS client. We would unblock our customers. It might open other doors to other pseudo files, procfs-like things, but it requires ODirect, so a lot of tools won't work out of the box. Customers will try to read the file. They'll have no idea why it's returning nothing, and that stinks. It will take a long time to reach our customers because it's a kernel change. And then there's the whole unsolved problem of every other client out there, BSD, macOS, Windows, clients that would need to change too. So what other options do we have? We could maybe vend a tool. We could maybe change the file layout to make this work, maybe change the file size to make this work. So let's look at some of those. So one option is we could vend a tool. Instead of letting the NFS client driver issue the read, we could issue the NFS read ourselves from a tool. So we could read beyond the inode length. There's no need for any driver changes, any kernel changes in Linux or any other client. It's a similar way to how Oracle Direct NFS works. That the read is issued directly from user space. And then, that all sounds great, but it requires some NFS client code in the tool, which is not ideal. We have to maintain this tool, vend this tool. If we have, NFS code now in it, it's a lot more overhead to maintain. So you can kind of see here how this works. It's kind of reversed, but the Linux client would create the session, do the mount, so it would look like a regular mount. You could still treat the NFS filer like a regular NFS filer, but using this new tool, it would be issuing extra, put file handle and read requests to do the read beyond the 0 length of the file. So that's great, but it has some challenges. Another option is we can change the layout. So the real problem here is, of course, that the 0 length file read is optimized out. So what if the files aren't 0 length? Do we have some upper bound we can put on the file length? So maybe. So with the existing layout, I don't know if you noticed that each user and group would be on its own line, and so if you have millions of users and groups, the file is millions of lines long. So maybe there's not a nice upper bound we can put on that. If you're of course then going to run into use after access issues where you look at the size of the file and it's changed because another user has written something. So there's challenges with putting an upper bound on that. So how else can we do this? So we could change the layout completely and have maybe one pseudo file per user or per group. And then we have a really nice upper bound we can put on each one of those pseudo files. So something like you see here, where there could be n number of user or group pseudo files in this directory, and then each one has an upper bound of whatever would be, say 1K. And your clients can all read that, they all can understand that, and all their tools will work. So great. The challenges with this are it's great, it's O of 1 to get utilization for one user, but a lot of these access patterns are not really, they need more than that. They need a lot of times to look at the utilization for all the users, because they're trying to search for which user has the highest. What's the noisy neighbor, or what do I need to look out for in the next 2 days before I scale, that kind of thing. So it's not great for those, because you're doing many NFS requests just to find that user. The other challenge here is that when we have n number of these pseudo files, we need to decide how to allocate inode numbers to each one of them. So today in the ZFS control directory, each one of these files, each one of these inodes has its hard-coded inode number way high at the upper range of what we can support. And so it's really easy to add one or two. It's really easy to add just a user space file, just a group space file, and we add 2 entries to this list, call it a day. But if we have a bunch of them, now we need a way to allocate inode numbers for this control directory, maybe keep them around, maybe not. And so it's a much bigger lift to go and change how we would allocate these inode numbers. So what's next? We have a lot of options here. Next is talking to customers, trying to find the option that fits best. It's not the end of the road by any means here. So we've been talking to some customers. We'll probably end up iterating on the pull request a little bit more, and trying to find an option that sort of works best for everyone. And then it's also not the end of the road, I think, for this kind of pattern in general, in terms of what we can use this pseudo interface for. There's a lot more you could do with read-only metadata, letting customers see arc stats and zpool stat live, maybe mutating things, maybe changing their user and group quotas, and then changing maybe advanced tunables that they currently can't today for those that want a lot more depth in the way that they configure their file system. So that's kind of what's next. And I'd love to hear any thoughts or suggestions on why you'd like to see us go this path or that path, or any other ideas you have. We'd love to hear. Yeah, that's pretty much it. So any questions?
Have you considered modifying for the control directory the stat so that it would return the actual size? Like you'd end up building the list twice, but it's not something you expect somebody's doing once a second, right?
Yeah, we could do that. I think our concern there was the time of use, time of check thing. It is something we could do though.
Do you know how the client responds if you just say the file's a kilobyte, but if they keep reading, it keeps returning stuff? Like if you don't return EOF, like cat would keep reading, right? This
may not be the case for other clients, but the Linux NFS client will stop after 1K.
Helpful.
Yeah.
Is the data just sort of the point in time snapshot of information at that point of time of the snap? Is it correlated one-to-one with a snapshot of the data set?
It's not correlated with a snapshot. So it's the live result of the current user and group quota, utilization, and settings for that data set, like at time of access.
Got it.
So it's not on a particular snapshot.
It's the real time.
Yeah.
And are you pushing all the data into like InfluxDB, so you've got history that way?
So that's potentially something we could do or customers could do.
Yeah.
So like not every customer needs the history, and so those that do, maybe it's worth the cost to do that. But we found that a bunch of them don't care and don't want that added cost.
Right. Yeah. It also seems like, in a way, maybe trying to push too much into NFS, and that you should just really have an API for it,
Right.
that they can call, and then you could do creative things,
Right.
and do faster lookups and have it cached versus. But I think it's super cool that you're putting the data in there. I think that's super handy that you can get fast access to the quota information. So
Yeah.
I think it's super cool.
Yeah. Thanks.
Have you guys looked at, maybe instead of being able to get all the data, what if it's like reports where it's like, show me the top 5, where you can limit and you have a better idea of like what's going to be presented. So you're processing it kind of on the back end.
Yeah.
And then you kind of have like a reports directory and you can kind of build from that.
Right. Yeah, like a report that would have an upper bound on size that would make this all a lot easier. We actually haven't looked closely at doing that. That's an interesting idea that I think so. I think some of our customers would be quite interested in. Yeah, thanks for the suggestion.
And kind of maybe on the same vein, what about padding out each row to be a fixed length? So if every row is padded out with just spaces at the end on like an extra comma separative field, so that everyone was 64 bytes, then you would know, there are X users, therefore the file will be that times +1 for the header times 64.
The tricky part with that is just that if a user
writes something in the meantime.
If a new user writes something, because it's not just the users that have quotas, it's all users.
Right.
So any new user writing anything would change the size.
Although the quota stats only get updated once per transaction group, so they're only going to change once every 5 seconds-ish. So maybe it's the whole small enough, but
we can get.
But then you're
there.
also, you're making somebody read a lot of space characters for no reason, right?
Yeah.
I got one question from YouTube. This is from Jan. Actually, now it's good. What if you return the map size possible and return the EOF early, as if the file had been truncated before step 3?
So I'm not sure if that question came through, but it was if we returned to EOF before the end, as if the file were truncated before the read. We could do that. The risky part with that, I think, is just the timing that if a user would write, within that period of time. Now you're kind of not.
What's your target accuracy for this?
Yeah. If we're
Looking at instant, or do I need a summary
yeah.
on an hourly basis?
So some customers I know have not really expressed the need for the real time, and just like an hourly update would be fine. The thought, I think, was that if we take this route and we'd say that this is real time, which is one of the huge selling points of it over the API or CloudWatch, that if we say that it's real time and then we're deliberately sometimes pulling things out, that's iffy. It's something we've looked at, but kind of ruled out because of that reason.
Next question. Do you consider making all file system properties readable through a pseudo file?
That's not something any of our customers have asked for, but I think that would be a really cool thing to do, and it would be pretty easy to do, just with what we've done here. We might run into issues with the inode allocation problem, but if we have to solve that problem anyway, then great.
And then the last part was, could you provide a pseudo file with a specific sorting order?
We could do that. Yeah, I think if I remember correctly, I think ZFS user space will already do this. I could be wrong there, but whatever the order we pull it out of, I think that's all stored in the ZAP. Whatever order we pull it out of there is the order that we would return it here, and I think that's already sorted today. Is it not?
I think it's sorted based on.
Is it by? Oh, by entry?
Yeah.
I see.
Like numerically increasing.
Okay. So then we could look at doing that. We have not looked at doing that.
Have you experimented with this, like in your example case where there's a very large number of users? If you're reading the file kind of in chunks, as the client would do, like what happens if the results change while you're in the, like you've seeked 2 megabytes into this file and now the results are different?
Yeah, so that it's all based on how ZFS like paginates through the ZAP. It's the same way. It's the same behavior as if that happened when you used ZFS user space or group space. So the results could change, then probably will change, like halfway through, but it's always the most real-time result for that particular user or group.
Well, I just meant with the sequential file mechanism from
Yeah.
Linux, if we're seeking and now the 64K barrier where we're reading in chunks doesn't land in the middle of a line. Could it like mess up the format where you're missing a new line because you
Or even
read
if
half the record on the previous read?
Even if it does, I think you have a problem with if I just do a read starting from offset 1 billion,
Yeah.
how do you know which user's line starts at offset 1 billion? Like, do you have to generate the whole report up to that offset to then give them that section of it?
If I remember correctly, I think that's how the seek file interface works, is that it will have to iterate through from the beginning. I think
that has a couple of problems. One, obviously now you have it's O of n squared
of
instead of O of n, which is probably going to be very bad for large, if you have a large number of users. The other problem is you might have garbled output. So like imagine that I'm getting it in 1 kilobyte chunks. So I get the first kilobyte, then now I'm going to get the second kilobyte. If nothing has changed, then it's going to work right. It'll just be slow. But then imagine if like a new user came in, or even an existing user's space usage increased or decreased such that the number of digits is more or less. So now the second kilobyte, I'm returning them the second kilobyte of the current report.
Yeah.
But they have the first kilobyte of the first report from a second ago.
Yep.
And the second kilobyte of the second report.
Yeah.
Then like those don't necessarily line up.
Right.
You could have a repeated digit or a missing digit, and then you think that somebody's usage is 10x or 1/10 of what it really is.
I think this is. I mean, I don't know how you would avoid this downfall with like an interface like seek file, but I believe that's a I don't know if you'd call it a flaw, but a behavior of seek file in any of these interfaces.
Yeah, I think so. I mean, I think that having a dynamic file, like essentially you're like modifying the file while somebody's reading through it, and you're modifying it by like shifting data around within it.
Right.
So I don't think it's possible to get a consistent result.
Yeah.
I think you need to either dictate, like you must read the entire thing with one operation. Like you cannot seek to non-zero value.
Yeah.
Right? You can only read starting at offset 0. We'll give you the report up to that point, and if there's more report after that, then just do another read.
Right.
Right.
Yeah. I mean, potentially like an argument for venting a tool. Like even if
like inventing a tool that would have this behavior where it's like, well, it says that the file is a terabyte long, but what I'm going to do is like read the first kilobyte. Oh, there's more stuff after that. Read 2 kilobytes, read 4 kilobytes, read 8 kilobytes until I've gotten like the whole thing in one read operation.
Yep.
Or you have to go down the route of having the one file per user interface.
Yeah.
But does the seek file interface do something for this? Because we would have the same problem with like the debug message kstat, right?
Yeah, I think that's true. I think
I don't know how different it is when you're doing it over NFS.
I think that the debug message kstat does have this problem.
Oh, okay.
it's just like, you put up with it. It's debugging.
Yeah, it's for debugging, so it's okay.
But it might be reasonable to say, like, think about your problem of like how many users do you really need to support,
Right.
and how big could the maximum report size really be? And maybe that's like 10 megabytes. Okay, so the pseudo file length is 10 megabytes, and you do it with one 10 megabyte read. That might be okay.
Yeah, it's true. Yeah, I think that's probably somewhere where we need a little bit more data on, like, realistically for these customers. Well, I mean, what are we talking about here? Are we talking about millions of users really?
Yeah.
You have to repeat this one, just 'cause Mike's done. Why not vend a tool, NFS utils, could also be a wrapper that you can ZFS client tooling can execute from Python?
Yeah, that'd be a cool thing. If on your client you could like run ZFS user space and it would go through this tool. That would be super cool. Maybe something down the road. I hadn't thought about that either. Any other questions?
All right, thanks a lot, Sam.
All right, thanks.